Welcome to our class today. We want to look at how to interact with the on-chain Noir ZK verifiers using Foundry and Sepolia. Last time we had, what we did was deploying our ZK verifier to Sepolia. So today we want to follow up and do verification and interaction. So we want to, first of all, verify that we have deployed. Of course, you can verify locally, or you can go on chain and see that your contract is deployed on chain. So those are the two ways you can verify. But our main target today is, after verifying that it's deployed, how do you then interact with it? That is what we'll be doing. And of course, you can interact with it locally, or you can interact with it on chain. So we'll be looking at both scenario. How do we interact with it on chain and locally? So that is what we'll be doing. So of course, I've noted in my introduction already that we already deployed. So far we know how to deploy. Of course, we know how to write this ZK contract, the verifier.sol. We've been writing that before. So we know how to write it. We know how to deploy it to Sepolia, our testnet. And we note also that Foundry allows us to interact with this contract, whether on-chain or locally. So it allows us. So today's goal, therefore, is to interact on-chain with the on-chain verifier using Foundry, and also understand local versus on-chain interaction. So you should know, how do you interact with it locally? How do you interact with it on-chain? So again, that is our target. Then verify proofs on-chain and emit events for auditing. So that's what we'll be doing in our today's lesson. Step one is we create a Foundry script that will assist us to interact with this contract. And the script we write is the interact.s.sol. So we add it inside the script folder, and then we load the proof generated by Noir, and then we call the deployed contracts verify function in that order. So that's what we'll be doing. So the interact.s.sol script is here. So this is what we just copy. Depending on your number of public inputs, you can edit this. You can see my public inputs are here. This is where I have my public inputs. So this is the point you can maybe just edit, and very few other points, but the rest will just remain the same. The rest will just remain the same. Now there's something I am importing at this point. Look at what I am importing. Import script from Forge script.sol, then import console, then also import Pong verifier from the verifier.sol. This is the contract we wrote. We import the contract also. Now, after writing this script, you would then you load the environment variable by running source.env. Remember, there's some space between source and dot. And then after that, you run the Foundry script. This is what then verifies, not verifies, interacts. You run forge script, script.s.sol. At this point, you add your Sepolia RPC URL, which I showed you how to get. And then you add the private key here, which again, I showed you how to get from MetaMask if you're using MetaMask. And then you write broadcast and so on. So this is the command we'll then be using. And when you use this command, what you expect to get is the verification result to be true if the proof is valid, and it will be false if the proof is invalid. Now, so let me just take you to the code. We look at it so that you know we're supposed to be doing it practically. So let me just share. Let me first of all open my program. Remember the script is inside contract. Now, we had already looked at this code, but the only thing I've added is what we talked about. When you come to contract and come to script, you will see that I've added interact.s.sol to assist us interact with this code. Interact with our deployed contract. Now, last time we added this deploy.s.sol to assist us deploy, and we did deploy it. So the only thing you're supposed to be doing today is to interact with our already deployed contracts. Now, this address here is where we deployed it. So that is, you go back and check your address where you deployed it. And this is what you write here. That's the address. It's not another thing, but it's where when you deployed, it told you, it gave you some address where you could then go online and see your deployed contract. So that address is what we then add here. We have two public inputs, and here they are. And that is what I've indicated here. Okay, so you have to declare your public inputs first of all. Define your public inputs before you declare them. So these are I told you that we would import. So you can see it's not a very complicated code that we are using. Now, if you want, most of my commands are already in my README. You can clone this and just get most of my commands here. My commands are already here right from creating the circuit, then deploying, then now we are at interacting with it. So this is deploy. When you're deploying, this is a deploy.s.sol command. After deploying, you can verify. There's verify proof.s.sol command. Now, after verifying, you can now interact with the verified contract. And that's why I'm telling you that when you clone this, then you would get all the commands I'm referring to. Okay, so this is the one we want to. Okay, I had another one. Let me just share another one. The one I prepared to share. I don't know if it's this one. Let me come to scripts. This one is not, does not have the script for interaction. So I think we can use this so that we do it afresh. All of us seeing what would happen. So if you're using this, you would want to first of all maybe interact with it, deploy it so that you get. But we had already deployed it. And we had the address. So if you want to see the address, you would come to verify proof.sol, and I had put the address here where it was deployed to. This is the address. So this is the address you would then copy and put in the interact.s.sol. It's the same address. Now the only difference is the one I showed you earlier had 2 public inputs, but this one has 4. So you would again have this 4 and just change that part where there was 2 and write for the rest remain the same. Okay, so I've come back to this. Now let's straight away go to the commands for interacting, because this one was already deployed and we've already written the script for interacting. And so there was source.s dot sol, that's a no source, then space, and then .env. That's the command. And then later on, just a minute. Okay, let's now do it. I don't know that it's this, whether it's, yes, it's this one. So I would get inside contract, cd contract. I'm inside contract. So while there, I would run source dot, there's some space, Okay, is it saying? I don't know whether it's because it doesn't want me to, because I had already run this command. I don't know whether it doesn't want me to run it again, because I had already deployed, and so it means I had already run the command. Just a minute. Does it mean I don't have .env? Let me just check again. It's supposed to be inside scripts. .env is here. Why is it saying that it cannot see it? Okay, where's this .env? Oh, it's inside contract. It's here. But it says it cannot see it. Just a minute, let me just establish something here. I don't know why it cannot see it. So CD contract. What is inside the contract? ENV is not seen. Oh, this one does not have ENV. Yeah, I was looking at something different. I was looking at something different. Let me just create the ENV file. .env. Oh, this one I have cloned it. So it's when you clone it, it comes without, you see, when you push it, because of this part, when you push it at your GitHub, because of this part, the env does not go. So when you clone it, it will not have the env. So that is what happened. Because I had, I just cloned it. So right now, when you run the command, we just ran the source.env, it should now run. Yes. Because you already have the env, it runs. Now what follows, therefore, because that is where the problem was, so we did not have env. I was looking at a different code, a different project that had env, but this one did not have because I cloned it. Now the command that follows to have us interact with this is the command forge script interact to that, but I need to change the Sepolia RPC URL which I have here. Remember, my private key is exposed because the contract that I'm using, my MetaMask account that I'm using does not have any ETH. So nobody can actually try to get anything from it. Remember to keep your accounts that have ETH very secure. You don't share the private keys. Now, so my private key is here. I just want to copy it and paste it here. I did not paste it correctly. So again, let me paste it. There it is. So I can now copy this command. Have I copied it correctly? Let me undo. I did not copy it the F. Copy this command. And ensure that this command is continuous, that it does not have breaking lines. If it has breaking lines, then it will not run. It has to be continuous. It's even advisable you can make it a continuous one line, but you don't have this 4 lines. Sometimes having these 4 lines, you may accidentally break the lines. Okay, they're supposed to be continuous as they are. Now it's still running, and it says the problem is with the path circuit target proof is not allowed to be accessed. Circuits target proof. And this is at line what? Which line? So I think it's just the issue of the path. The issue of the path. Let's come to this interact and see how we defined our path. So what I'll do, where the problem is this. So this is what I'm supposed to change. Let's see if this will work. Just retyped the whole of it. I think we can change the code for interacting. So let me just write the code I want us to use. I want to write it here. I want to replace this. I want to use this forge. It's almost the same, but I want to change this to the address where I deployed it. Or before we do that, we can begin by, first of all, deploying it. Now we get the address. Let's first of all deploy it, that we get the address. So to deploy it, this is the command I want us to use. I just want to change the Sepolia RPC with what is here. First of all, deploy this. So I change this. Also change the private key. So I can use this to deploy. And as I said, it should be continuous. Oh, I did not put the address deployed at, what is that? What is it saying? Error, invalid value. Okay, let me remove this. Remove this for the time being. The command we are using is this. It has just been deployed. So the error was just said I was supposed to just remove what was I had pasted there. That's what it wanted me to remove. That was the error, but it has now deployed it to, this is what I wanted, the address. The address is here. So if you want, you can go there and see. You can go online and see it because it has already been deployed. So let's just go online and see where it has been deployed. Now, seeing where it has been deployed online is one way of just verifying that it's deployed. But of course, I've said we can also verify it manually, locally. We can also verify it locally. So this is where it has been deployed. This is the address I've just copied and pasted here. So when you press enter, you're supposed to see the contract and is here. It says we deployed it 2 minutes ago. You can see this. And it has not been verified. You would be seeing a mark here. You would be seeing a mark here when you verify it. There will be a mark there that it has been verified. Oh, it's now verified. Okay, this one mine is ticked because I had deployed it earlier. So when you just redeploy, I deployed it earlier and verified. So I've just redeployed. That's why mine is already, yeah, there's a tick there and you can see when the contract is here. But yours, if you are not deployed it, you can't see this. If you are not deployed and verified, this one cannot be seen. For me, I deployed and verified, so you can see my contract is already verified. is a compiler, and so on and so on. Now, but I wanted us to verify manually, so I just show you or locally. So I'll show you the command for doing that. Because mine, since I had already verified, it will just tell me that. It will tell me that the contract is already verified. So to verify, here's the command. This is the command. And this command, we just need to change the address. And our address is here. Just change the address. So that is the address changed. Then we also need to change, this is the compiler version. I showed you how to get it manually, but again, when we went online, we saw it is already there, but you can check for it online using our other lessons I had already shown you. Now, the other thing we need to change is the Etherscan API, which is here, API key. So I just change this, the correct one. And again, I had shown you how to get it. And then run this. I'll run it down here. Ensure there is one continuous. Now it says, starts verifying, compiler version, optimization, contract to verify that is already verified. So it skips that process. And I already told you that for me, I'd already verified, and therefore, since I had already verified, you just tell me that it's already verified. But for you, if you are not verified, then it's supposed to give you some status of verification and so on. Now you can check the status. Now, if you had verified, it's supposed to give you some GUID number. For me, I'll not get the GUID number because I had already verified, and so I lost it. I lost the GUID number. But for you, if you ran this command that we've just run for the first time, then you'll be seeing the GUID number. And so to verify that it has been verified, you would take that GUID number and put here. That GUID number you would put there, and then change this, and then copy the entire command, and then run here. It's supposed to tell you verification status. That's what it's supposed to give you. Verification status. So we have deployed and verified, but our target was to interact. Our target was to interact with the verified contract. Now we already have the script for interacting. And the command The command for interacting that we had talked of is here. So let's again replace the API key. No, we don't require the API key, we require the private key. Let's replace the correct command for the private key. And then the RPC URL, again replace this part. Then you copy this. We had already done this, so we don't require to repeat it. So you can just use that. Let's see if it will accept this time. I don't know why the problem is this command. Let me just again check. Now, so I think it's saying that we are running our script inside contract, but the proof that is supposed to be verified, this proof that is supposed to be verified is inside circuit, and we are running, so it cannot read a proof that is inside circuit from the contract. Sorry. So we're supposed to allow parts, supposed to allow this part. Let's just try this command and see whether it will work for us. Let's just try to allow it to read an expected argument, allow paths. Okay. So this one again is not working. So if this is not working, let's check our Foundry and see whether our Foundry allows us to read from that. Let me just try to edit it a bit. I don't know whether, because I've said access, read, write from this. Let me see whether that will work. I can even go to the earlier command that was rejected. Then what the problem is, when you come to our circuit, we have no target and we have no proof. So I thought we already had that. Since I cloned it, it did not come. I pushed it online, so it didn't go with the target. So when you clone it, it doesn't come with the target. So supposed first of all create target. So CD circuits, CD circuits. So I think that is where the problem, we've been getting a problem. It cannot read the proof because there was no proof. So what we're supposed to do is Nago compile. This was the target. Yeah, now we have the target. And let's do build.sh to generate our verification key And then down here, generate verifier.sol. Okay. Let's get out of circuits and get inside the JS, and then just generate the proof. Yarn generate proof. Yarn generate proof. Let's just do that. Yarn generate proof. Okay, so let's first of all install yarn. Yarn install. So that it installs the modules. And then after that, we can do yarn generate proof. Okay, the proof is now there. Good. Now, since we have the proof, we can now try our commands again. Because it's this proof that it was not able to read. It was not able to read the proof. It was not able to read because the proof was not there. I forgotten we had a pull requested. We had committed to our GitHub, and so when we cloned, I saw my target is inside GTIG now. That means that whenever I do commit it, the project, the target does not grow. And since target does not grow, when I then clone it, it doesn't come with the target. Good. I think we are now ready to interact with our contract, which we had already deployed. So our key, private keys here, and then our UPC is here. And I think this time should work. Let's see. Must get in outside circuits and get inside contract now. It has successfully done up to this point. Let's just wait for it. And then talks about allow path. Where did I get this from? No, this is not the correct command. This part, remove this part, this part. Let's use this. The problem is I think would be because it has multiple lines. Now, where the problem was, it wanted me to do again forge build first before I do forge script. So I did forge build, then did the same command we were doing. And then you can see now it says the verifier is deployed at this. So we have now verified, we can go online and see that our contract has now been verified at that very point. That is the address we could go to. And in fact, the address has been written properly here, that this is where it has been, where the verifier has been deployed to. So it just wanted us to, first of all, do forge build, because it's like the proof that we had was not matching with what we had generated earlier in our contract. So doing forge build now was to just ensure that it's the same proof for the same contracts. That is what we have just done. Now, but we've verified, we've interacted with this we've interacted with it off-chain. But if you want to interact with it on-chain, you may want to also create another file, which we call the home verifier with the record. So this one then stores your verification on-chain. So this other file, you would create it inside inside our tests, inside our script. So inside our script, you would come inside our script. This is where I have the contract, and then we have the script here. So you want your verification to be stored online. You will create another file here. And this other file, when you right click, call it store interaction.sol. And then the command, what we would then use as the code there is what I want to paste. This will be the code. And this code, you can see you have to mention where the verifier address is. Then also you have to remember to declare your public inputs. If there are two, if there are several, you have to do that. And that is it. So when you run the command this time, it will go straight to online, on-chain. You'll be storing your data on-chain when you run the command this time, so that you can now verify, you can now interact with your contract on-chain. Remember, we were just interacting with it locally. But what is very important to us is to have to interact with it on chain. That is what is very important to us. Now, so we've just done the code for storing information on chain so that we are able to verify on chain. So we may also want to deploy it, and then we've just stored. After storing this on chain, you can execute by running some command, and I'll show you what that command is. But let's just be able to see the command for deploying now, because when you look at what you've just written, you see formally we've been deploying our verified.sol, but basically that is not what you're supposed to be deploying. What you're supposed to be deploying is this what is that? We're also supposed to have the home verifier with the record. Home verifier with the record. I just need to create that. Not only create it at the same level of the verified.sol. So the same level of verified.sol. This is where, not inside the script, but our verified.sol is at this level, not this level, is at this level, is just inside our contract. So we come inside contract here and create another folder, now file, and call it home verifier with the records. So this is what we will then be deploying, but it will go with the verified.sol because we want to import verified.sol. So we want to import the verified.sol, and this is the code. So you can see I've said import verified.sol. So this therefore is a contract we will now deploy. And when we deploy it, this is what goes online above, and below it we will have the verified.sol. So we will not be deploying the verified.sol, but we'll be deploying the home verifier with the record, so that it can now assist us to do interaction with our deployed code, deployed contract on chain. So that is what we'll be doing. So from today hence, we'll now be deploying this and not the verifier.sol as we've been doing. We've just been deploying the verifier.sol because we've been learning on how to do deployment on Sepolia. But now that we know, then we now go to what happens in real life. In real life, you are deploying the home verifier with the record, and the command that we are using to do that is this command. So this one you just change again the URPC, just change the RPC with the exact one that you obtained the other day in our earlier lesson. So the RPC code key, just put it here. And then the next one is our key from MetaMask. And again, I put it there. And remember this time, I've remembered the forge command so that we don't move round and round for the same thing. So what we are doing now is just to deploy this contract, the new contract now. What we are deploying therefore is the home verifier with the record.sol. And we will go on chain and see where it's deployed. It has, what is it saying? The deployer is you, and then deployed to this, the address. And then we have this transaction hash, and this is very important also. We'll be using it later. It's a very important component. We'll be using it later. So this contract is now on chain. Let's just try to see where it is on chain. The one we've just deployed now. Before we do verification, before we do anything else, let me just copy it and then we go and check. Let me copy the address. That's where it's deployed it to. So I paste the address and press enter. And you can see this one, it just deployed 2 minutes ago. And let me just show you, it has not been verified. It has not been verified. So when you click on this contract, this is what you see, because it has not been verified. But once we verify it, it changes, and we have the exact thing that we have. The exact thing that we have locally is what we then have once we verify it. Once we verify, you can see even the compiler is not here. There's nothing here. But once we verify, all these will change. Okay, this is how it appears before you verify it. We'll come back here after verifying and we'll see things will be different. Okay. Now that we already have the store interaction.s, let's run that command and see what we get. So again, I'll stop sharing this. Now we already have, inside our script, we already have the store interaction.s.sol. So we just want to now begin interacting with it on chain. So I'll just change the commands we require here. The urpc, just change it. It's no problem, I can just change the entire thing here. And then the private key, just come again and copy the entire thing. Private key and change it again. Then copy this. And run it. Okay, there are a few things I need to change. One of the things I need to change is I should come here and the address, I need to change the address because this is no longer the same address. That is one mistake we did because we were just deployed this to a different address. And our address is now here, this one. So I just need to change that first of all. Yes, for continuity, let's first of all look at what we have in our PDF. As for continuity and completeness. Now, this is how we interact with your contract. When you go on chain, you see read and write. So read contract. When you are reading contract, there will be no gas cost. Does not change blockchain state. The example would be the verify function. Now, what this means, therefore, is when you're doing it, you want to read your contract, there's nobody charging you for doing that. And what about writing? Writing, it will cost gas, and then it will modify the blockchain state. And the example will be verify and store, that is function. So, and we've said that this process can be done both locally, or you can also do it on chain. So if you're storing verification on chain, we've already said that you would first of all create this verifier with the record.sol inside the contract at the same level with the verified sol and or the Cyprian verifier app.sol, and this would be the command that you paste there, not the command, but it will be the code that you then use inside that file. And then you would deploy, and we just saw how to deploy using this command. You can say, can begin by forge build. And you remember to some point we did not put that, and went round and round until we had to put it forge build. And then you run this command, it will deploy this, and we saw how it will then look when you go online. You can verify the contracts. You can verify if you want. Because I'm saying if you want, because it's not compulsory at this point. But what is compulsory that we want is how do you do on-chain interaction? And for you to do on-chain interaction, we said create a script and we call it store interaction.s.sol inside the script and paste in this code. After pasting in this code, you want to do on-chain write execution. You replace, this is what you would use, this command is what you would use. But just replace this with the address you obtained when deploying. So this is the command, and it's the one I want to use. This source space.env, and then forge script, interaction, and so on. And then you put that, the same command we were using. And then what do you expect when you do this? Forge will compile, then submit a transaction to Sepolia that calls verify and store. Transaction logs would appear once mined. Then verify and store writes last verification and last public inputs on chain. So that will be written. And then the event proof verified is emitted. If the proof is valid, there'll be a console log that shows verify and store returned true. Okay, after that, you just go on chain and check and see whether the verification has happened and so on. So that is what you would then do. Now, I think next time we just meet and just do the on-chain deployment and on-chain verification from the start without doing it, first of all, locally, so that we just concentrate on doing it on-chain. I think that is what we'll be doing in our next class. So we'll repeat this class, but not from the start, just concentrate on doing it on-chain alone. That is what we would then concentrate to in our next class. Thank you.